For the fuels lab, I wanted to leave some notes for teachers just to emphasize a couple of things in the lab setup. So for the unaltered setup, one of the very important pieces for students is that they maintain a constant amount of water in the setup and that they exchange it out for each trial. One of the interesting pieces for this lab is that the container, the metal container, heats up quickly, and then when you're switching out the water, it also will heat up the initial temperature of the water. So you'll notice in the video when we were waiting for the initial temperature, sometimes we had to wait for quite a while because it would initially heat up the water and then it would cool down. And we wanted to get an accurate starting point so that we could look at a correct change in temperature over time. So ideally, one would have multiple cans for setup, and then each trial they would have a new can, or at least 2 or 3 cans, so that one had the opportunity to cool down for the next trial while you were using a different can. So if you're doing an error analysis with your students, that's one thing potentially that students could bring up. And if they don't, that might be something that you mention. You also want to be consistent about the amount of liquid fuel that you use. So we used 15 drops of the liquid fuel and then letting that burn all the way out. Trying to be consistent with your drop size if possible. The ethanol comes out very quickly, so sometimes hard to count the 15 drops. The isopropyl alcohol is a little bit easier to handle. For our fuel containers, I just use some of these tea light containers. I just pop the candle out and then put the drops in there, and that worked really well. We also, for our paraffin wax candle, was just a little tall, so we just melted the bottom and then placed it in one of the tea light containers to hold it up. The other thing we tried to keep consistent between the trials was the distance between the flame and the bottom of the can. We tried to keep it consistent on the unaltered setup and then on the altered setup, knowing that there'll be a little bit of variation there, and that may be something that your students notice, and again, maybe something to mention to them if they don't notice it. Let's see, what else? The other important piece for students to know is that the bottom of the thermometer should not touch the sides of the can or the bottom of the can, just because it's very thin aluminum, so it heats up very fast and will change the temperature of the thermometer enough that it will make a significant change in the calculation. So you want to be sure, and that's why I fussed with it so much during the video, just trying to be sure that it is touching the liquid, ideally submerged, but depending on how much water you're using, at least touching the liquid and not touching the sides or the bottom. Of course, the more water that's used in the can, the less the delta T will be. So I use 25 milliliters. That's an area where kids in their groups can decide what to use. That may be something that they're aware of ahead of time also. You know, sometimes they want to start with, well, we'll use 100 milliliters of water, and that's a lot of water to heat up. So I would counsel them to use on the smaller side of the water, but you want to use enough so that your thermometer can reach it without touching the bottom of the can. You might consider doing a couple of quick and dirty runs just so they can get a feel for what the variables are and what are the things that they need to attend to in their experiment before you start doing actual data collection. For the altered setup, this is where I would let students choose. So we would have a discussion about all the ways that heat is lost in the experiment, and they're quite good at coming up with those ways. So you know, a lot of it is lost into the air, around the system. So after brainstorming together as a large group, students can then go to a small group and discuss together how would they like to adjust their setup to maximize the transfer of heat energy into the can. And we're always shooting, of course, for 100% transfer, still knowing that when we alter it, we won't get 100%, but we're trying to get as close as we can. So like I mentioned in the video, I did a lid, kind of a cozy around this, and then raised the height of the fuel. People may have different ideas about what they'd like to use for their cozy, like what material they'd like to use. And this is, I would give students a wide berth here to try things out, just paying attention to, you know, is that a flammable material or not? Because the flame's certainly going to be close to it. The water or the can retaining heat is even more of an issue with the altered setup, because it is doing a better job of insulating. So it's holding the heat in even better. So you may notice that the initial temperature doesn't actually fall down to room temperature because the water is warmed slightly by the retained heat in the can. So an even better reason to have more than one can per group, just to give the can time to cool off. Otherwise, I would say it's pretty straightforward. It takes a little bit of time because there's a lot of trials. So, you know, giving enough class time to collect quality data. One variation you could do is to have each group just collect data for one fuel. That way they can get maybe even more than 3 trials, more than 3 very good trials. So we're going for quality here instead of you know, trying to get all data for all of the fuels. If they just attend to one, they can get more trials and more quality trials, and then groups can share out their results and then do an analysis from there. So that's another idea. If you have trouble locating any of these items around you, so for example, if you have trouble locating a paraffin candle, you might use this video for the paraffin data and then have students collect data in real time with the other substances. So you kind of mix and match depending on what your classroom situation is. So otherwise, I think that's all. Good luck.